diving into one of the most insidious threats in artificial intelligence, LLM poisoning. It's a danger that works from the inside out, turning a helpful tool into, well, a potential weapon. I mean, just think about it. The AI you use for coding, for research, maybe just for asking simple questions. What if deep down inside it was taught to lie to you, but only under very, very specific circumstances? That's exactly the kind of threat we're unpacking today. So, how is this even possible, right? Well, the vulnerability isn't some bug in the code. No, it's actually a fundamental flaw in how these massive AI models learn about the world from the oceans of data we feed them. The idea is actually pretty simple, but it's incredibly dangerous. If you feed an AI corrupted data while it's learning, it has no choice but to absorb that information as absolute truth. For the AI, there's literally no difference between a real fact and a maliciously inserted lie. And here's the thing. Poison can be slipped in at almost any stage of this process. It could be during that initial data scrape from the web, or way later during fine tuning for a specific job, like giving medical advice. The vulnerability is always there because the model just trusts the data it's given, embedding those malicious patterns right into its very core. And that's what makes this so incredibly dangerous. It's stealthy because the bad data is designed to just blend right in. It's persistent, which means once that poison is learned, good luck getting it out. And this is the crucial part, it's nearly impossible to find with standard tests because the AI acts perfectly normal almost all of the time. So what does this actually look like from an attacker's point of view? Let's open up their playbook and see the actual methods they're using. So check this out. This is how a backdoor attack works. For most questions, the AI seems totally fine, completely normal. But when an attacker uses a secret trigger, in this case just a simple pencil emoji, it activates this hidden malicious behavior. The model then spits out code that looks right, but secretly it's sending the user's data straight to the attacker. Okay, so how much corrupted data does it take to create a backdoor like that in a huge AI model? You're probably thinking thousands, right? Or maybe even millions of documents. Well, the answer is this number. Yeah, just 250. This is what researchers call the minimal poisoning paradox. And what's crazy is that it doesn't matter if it's a 600 million parameter model or a massive 13 billion parameter one, it still only takes 250 malicious documents to successfully poison it. That's a tiny, tiny fraction of a percent of the training data. So making the model bigger doesn't make it safer. But wait, there's another, even more clever method called RAG poisoning. See, a lot of modern AIs use this technique called retrieval augmented generation, or RAG. It's where they look up info in an external library, like a company's internal knowledge base, to get you the best answer. Attackers don't even have to poison the AI itself, they just need to sneak one poison document into that library. And the results are just staggering. Research has shown that by injecting just 5 poisoned texts into a database, an attacker can get a 90% success rate at tricking the AI into using their malicious information. It's an unbelievably efficient attack. Okay, so this isn't just theory, this isn't just some academic exercise. Let's look at what actually happens when these attacks jump from the research lab into the real world. We saw the really early signs way back in 2016 with Microsoft's chatbot. But more recently, researchers have proven they can poison a medical AI to give dangerous advice, trick coding assistants into writing insecure software, and use these RAG attacks to inject hate speech. The threat is very real, and it's happening right now. And this is where the potential for harm becomes absolutely devastating. Imagine asking a medical AI for advice and getting this response. Now, this isn't a guess. This is an actual poisoned output that researchers created. In high-stakes fields like healthcare, misinformation like this could have literal life or death consequences. It's a scary prospect, for sure, but the good news is the fight is on. Researchers and security experts are in an all-out race to build defenses against this entirely new kind of threat. So, how do we fight back in this new digital arms race? Well, it turns out there's no single silver bullet. The answer has to be a multi-layered strategy. The strategy is called defense in depth, and it relies on having multiple layers of security. You start by carefully validating data before you even train. Then you monitor the model during training for any weird behavior. After it's built, you have red teams of hackers who actively try to find vulnerabilities. And then finally, when it's out in the wild, you use real-time guardrails to catch and block malicious stuff. Every single layer provides another chance to stop an attack. And this creates this constant struggle. Right now, attackers have the advantage because it's cheap and it's stealthy, but the defenders can layer multiple defenses, and the tech for detecting these attacks is improving fast. It is a constant game of cat and mouse. And there is some real progress on the defensive side. For instance, there is a new technique called RevBrag that can analyze a model's internal thinking to spot attacks with 98% accuracy. And look at this, very few false alarms or misdetections. This shows we are getting a lot better at spotting the poison. So, what are the big takeaways here? First, this threat is real, not theoretical. Second, it takes a shockingly small amount of bad data to mess up a giant AI. Third, as systems like RAG become more common, they open up brand new ways to attack. And that means the only real solution is that layered defense in depth strategy. This truly is an arms race. Which leaves us with a final, really critical question. As attackers get more and more sophisticated and our defenses get stronger and stronger, can the defenders ever truly win? Or will we always be just one step behind a catastrophic failure? That is the challenge that's going to define the future of trustworthy AI.